Well, if you were watching this, you are definitely a nerd because you wanted to see me finish the review for the prerequisite exam. But I love nerds. I appreciate you guys. Okay, so let's see. Got to here with the class that I got the least amount of time with. So we got to talk about how to solve absolute value equations. Absolute value does not mean make things positive. That's what people think. That's not what it means. Absolute value means how far from zero is this number. Now, you don't know what this number is, but absolute value says how far from zero is it. And since absolute value is going to talk about a distance from something, every value that comes out of these bars will end up being positive because there's no such thing as a negative distance. So what we're saying is 2x plus 1 could be a positive number, and we want that to be 9. But it could be a negative number. We would still need that absolute value to equal 9, though. This means that you actually have two different questions. You have the question where the 2x plus 1 was a positive number, and if 2x plus 1 was a positive number, then wrapping it in absolute value bars would be unnecessary. And then there's the negative case. And the negative case says, 2x plus 1 could have been a negative number, and those absolute value bars would have hidden that fact from you. That might not be how you were That might not be how you were taught how to do that. You might have been taught just to make this negative, but there are reasons why I don't do it that way, and those reasons will become obvious in chapter 2. I'm now going to solve both of these things for x. Subtract a 1 from both sides. And then divide both sides by 2. One of my answers is x equals 4. Let's check it to make sure it works. 2 times 4 is 8. 8 plus 1 is 9. Absolute value of 9 is 9. Good, it works. Now this one. You have two options. You could distribute the negative to these two things and then solve for x. Or you could divide both sides by -1 right now. It really doesn't matter. In my classes that saw me do this question, I divided by 1 every time. But now that I'm looking at it again, I'm thinking, I think most students might distribute the negative sign. So because of that, I'm going to go ahead and distribute the negative sign. It honestly does not matter. Now let's solve for x. Add 1 to both sides. You'll get -2x equals 10. And then divide both sides by -2. And you will get x equals -5. Last thing you should do is check your solution. 2 times -5 is -10. -10 plus 1 is -9. Absolute value of -9 is +9. So both of those answers work. Now I am going to skip around, but let's talk about number 30. If you are just mimicking a process, you're trying to memorize the way something is done, instead of understand what is happening, you might right now be setting up your positive and negative case before I do. But you don't want to do that. The reason why is because if you understand absolute values, you know that anything that escapes these bars must be a positive number. There is no way that absolute value of something can equal a negative number. So this question is actually no solutions. Think it's smarter, not harder, okay? Let's say you forget to do that. Set up your positive and negative case, you solve it all the way out, you get 2 answers for x. As long as you're in the habit of checking your answer like I just did, you'd find out that both answers fail. Both answers say something like +12 equals -12 when you check them, which is clearly not true. Let's go ahead and move on to number 31. I have to solve my quadratic. It doesn't say how to solve, though, which means you are allowed to choose whichever solving method you prefer. Some students will just immediately go to the quadratic formula. I am not a fan of the quadratic formula. I would rather factor when I can, and you know what? This factors. If you were trying to track down the two numbers that multiply to 15 and add to -8, you'll see that they do exist, and since there are two numbers that multiply to 15 and add to -8, solving by factoring is the much simpler method. Let's see. You need two numbers that multiply to 15. You need those two numbers to add to -8. Got a little close to my answer right there, whatever. These two numbers would be -3 and -5. let's put those in our parentheses. I have x minus 3 and x minus 5, but I still have this equals 0. Because it says equals 0, and because these two things are being multiplied to each other, you're asking yourself, well, what's the only way possible to multiply numbers and get 0 as an answer? Well, that could only happen if one or both of the multiples themselves are 0. All we have to do then is set the multiples equal to 0, I guess they're called factors, and get x by itself. Add 3, you get x equals 3. Add 5, you get x equals 5. Those are your two solutions. Most quadratics have two solutions. Not all, but most. Some have none, some have one. So I would like to draw your attention back to number 25, up here. If this had said equals 0, you would have the ability to solve for x, and your solutions would be x equals positive 3, x equals negative 16, because that's what would have made the inside equals 0. See, it's what made the inside equals 0 both times. And this method, which is kind of a gimmick, cheating a little bit, I like solving quadratics using this method because I could see my solutions in this step. If this had said equals 0, then the fractions negative 2/3 and positive 5/2 would have been what make these insides equal 0, and they would have been my solutions. So I do like this gimmicky method because it'll get me to solutions pretty quickly. Instead of having to set this and this equal to 0 and getting x by itself, I could just say, oh, what makes the inside of these equal 0? It's up to you though. And yes, you could use the quadratic formula as well, but yuck, I hate the quadratic formula. I did number 33 with one of my classes. But I'm going to go ahead and do number 34 because it'll be fun. And whatever we do in 34, if you want to do it to number 33 because I didn't do it with the other two classes, feel free. Or one of the classes, I can't remember. It's been a long day. Anyway, let's start getting x by itself. By the way, I could solve this by factoring if I really wanted to, but I'm going to show you other methods. Let's start getting x by itself. I know they're frightening, but you're going to have to deal with the fraction here. Divide both sides by 9. Uh-oh, threw my pen. Lost it. X squared equals 4 over 9. Like that. If you would like to cancel a square, you must use its inverse operation, which is square root. When you cancel a square with a square root, you must remember that you're going to end up with a positive answer and a negative answer on the right side. The reason why that happens is because a positive number squared is a positive number, but a negative number squared is also a positive number. And this is not scary. If you have to take the square root of a fraction, it's just square root of the top and square root of the bottom. Square root of 4 is 2, square root of 9 is 3. Those are your two solutions. There it is. 35 and 36 are literally just following the order of operations questions. They're PEMDAS questions. Can you follow the order of operations? The P stands for parentheses, and what that means is, can you clean up something inside of parentheses? If you can, you should start there. And yes, I can. 2 minus 5 is negative 3. Next is exponents. This number has an exponent. Negative 3 squared means negative 3 times negative 3, which is positive 9. Next would be multiplication if you have some. We do, right here. 4 times 9, that's 36. Then division. 36 divided by 6 is 6. Lastly, the addition subtraction. There it is. All that stuff equals 1. You go ahead and stretch your legs and practice on 36. Look at all the stuff on the back. Okay. I think I'm going to do number 38 because, eek, fractions, right? Big old scary fractions. It just says evaluate the expression. That means what does it equal? Not solve for anything. I told you what A and B are. Literally take A's value, B's value, substitute it in everywhere you should. And please, please, please always use parentheses when you substitute. Okay? So I've got 3 parentheses, A, over. Technically, should I put parentheses around this B? Yeah, I mean I should. But since it's the only thing down there, it's kind of a waste of time. That's the only reason why I didn't. Minus B is going to go here in these parentheses. Notice the minus sign is not inside the parentheses. This minus sign would be handled after exponents according to the order of operations. So it's not -4 all squared. No. It's negative of 4 squared. Plus A is 12, B is 4, all over 16. Remember, this is a no calculator test. 3 times 12 is 36. 4 squared is 16. 4 times 12 is 48. (36) divided by 4 is 9. 48 divided by 16 is 3. 9 and 3 add to 12. 12 minus 16 is -4. There you go. Okay. 39 and 40. I mean, this is straight up and down Algebra 1. Really just solving a multi-step equation. And it actually doesn't matter which one I choose to do because they both have this skill that I'm really looking for here. And that is, does the student realize that you have to distribute this negative sign? So it doesn't matter which one I choose to do. In this one, you're distributing a -1. In this one, you're distributing a -3. It doesn't matter which one you do. I guess I'll do 40. Why not? It feels good. Anytime there is a symbol in front of a number, that symbol belongs to that number. So I am distributing a -3. See what we get here. We got 14 plus 3n equals 8n. Now I'm distributing -3 times n, -3n. -3 times -4, positive 12. If you forget that you're distributing a -3 and you just distribute a 3, you'll still have a minus sign here, and that answer will be wrong. And unfortunately, if it's a multiple choice question, that wrong answer will be waiting for you. Of course, if it's a fill in the blank, your answer is just wrong. Wrong, wrong, wrong. Okay. These are like terms. 8n minus 3n is 5n. Let me get all my n's to one side, all my not n's to the other. And it doesn't matter which side you choose, and because I don't feel like goofing around with negatives, I'm going to subtract a 3n from both sides. And at the same time, I'm going to subtract a 12. That way I'm getting the not n's to the other side. 14 minus 12 is 2. Oh, check that out. 2 equals 2 times n. Just divide both sides by 2. And what you see is that n is 1. Easy peasy lemon squeezy. Alrighty, solve for x. 41 and 42. Yeah, look at all those fractions. I think I'm going to go ahead and do both of them because, fractions equals scary for a lot of people. So I'm going to go ahead and do both. Let's start getting this x by itself. You add 2 to both sides. You see, order matters for division, okay? And I can tell you that there are a lot of students that right here would say, oh, I'm just going to divide both sides by 16 and I'll get my answer. But no, that won't work. You see, the problem is that x is in the bottom of a fraction. Your solutions can't be in the bottoms of fractions. That doesn't make any sense. So we can't have that x in the bottom of that fraction. We have to get it out of the bottom of the fraction. A fraction bar means divide by. This says 16 divided by x equals this 48. Dividing by x is what we currently have, so the inverse operation of divide by x would be times x. So what we're going to do is multiply both sides by x. On our left side, the x's cancel and leaves us with 16 equals 48 times x. Now you can divide to get x alone. So get rid of this times 48 by dividing both sides by 48. That gives me x equals 16 over 48, but you must reduce your fraction. You could divide the top and bottom of this by 16, and you will get 1 over 3. Those of you that have been paying attention to the review for the last couple days and to this video will have noticed that 16 going into 48 3 times has already come up in this packet like 3 different times. It's because it's one of those multiples that people forget, so I like to put it in there a lot. Okay. For number 42, there's 2 different ways we could do it. We could either right now make that 2/5 go away by canceling it on both sides, or we could do what I think most students would do, and that is distribute the 2/5. So because I think most students would do it this way, that's how I'm going to do it. Showing the work though, 20. You know what? I'm going to call it 20 over 1. Because when you multiply fractions, it's just straight across the top, straight across the bottom like that. So we'll call 20 over 1. Here, when I multiply straight across the top, straight across the bottom, I will get 2 over 10x plus, straight across the top, straight across the bottom, 40 over 8. Whoa. It's an aneurysm, I think. 40 over 5. There we go. Well, you know 2 over 10 reduces because you can divide the top and bottom by 2, which you actually could have done that right here. You could have cross-canceled. This 2 cancels this 2, leaving you a 1 over 5x. And 40 over 5 is 8. Oh, that's where I came up with that 8. I must have been thinking ahead to the answer already. Let's get x alone. Subtract 8 from both sides. I ran out of vertical space, so I'll scooch over here. 2 minus 8 is negative 6. If ever you would like to make a fraction completely disappear, both its numerator and denominator disappear at the same time, all you have to do is multiply both sides by the reciprocal fraction. That means flip it over. If ever you just don't feel like dealing with fractions in general and you just want the bottom to go away, you just multiply everything by the bottom. Multiply everything by the denominator. Either way, this says 1 over 5. So if I multiply by the reciprocal of 5 over 1, which is just 5, my 5 and my 1/5 will cancel out, and it will leave me with x equals negative 30. Woohoo! And then, lastly, 43 and 44, I'm only going to do one of them. I'll do the one that looks scarier because, eek, fractions. I'll go ahead and do 44. This says f of x equals this equation. So what is f of x? F of x means this thing is a function and x is its variable. And notice there's an x in these parentheses. There's x's on this side. Notice this x that should have been in here was replaced by a negative 4. What that means is go over here and also replace its x's with negative 4. That's what that means. Always do substitutions with parentheses. So everywhere I used to have an x, I'm going to use a set of parentheses. On the bottom of this fraction, should I put parentheses? Well, technically, yes. But do they make a difference? No. I'll write them anyway. But do they make a difference? No, it's just the only thing down there. All right, let's drop a 4 into those parentheses. Put a 4 in for there, so it matches that. Put a 4 here and here. -4, -4. Beep. Let's see what we get. Well, -4 squared, that means -4 times -4, which is 16. 8 divided by -4 is -2. And I still have that -1 at the end. 16 minus 2 is 14, and -1 is 13. So there is the final result. Remember, the test is no calculator. So what formulas do you have to have memorized? I need you to know the slope formula. I need you to know slope-intercept, y equals mx plus b. You might want to know point slope. I can't remember if I used it or not, so I'll write it. That's y minus y1 equals m times x minus x1, where you would be substituting a coordinate in here, x, y, right there. Leave the variable x and the variable y alone. Quadratic formula, we used x equals -b plus or minus root b squared minus 4ac all over 2a. Axis of symmetry for a quadratic, we did that one. That one is that. I might not have said the actual vocabulary, but that is the equation for the axis of symmetry. It goes right through the vertex. X equals -b over 2a. And what else? The distance and midpoint formula, we didn't do any distance, but it's literally the Pythagorean theorem. Midpoint, yeah, that one is just average the x's and average the y's. If it wasn't in this review, it's not on that prerequisite test. I hope that nobody's freaked out, and I hope that you enjoy your weekend, assuming that's when everybody watches this video. Anyway, until I see you again, appreciate you, nerds.